Hey everybody, it's been a while since I've given you all an update. We are on our way to almost inject my ions into the electron string. I've shown you before the amazing setup we have achieved here. There's the helium vat, of course, looking into the ESAs, and of course our connection to my LMIS system. Our data acquisition post and voltage control. The good old Cyclops scope is no longer in use, and we have now been upgraded to this scope over here. And I'll explain to you what that beautiful signal is very, very soon. Here's our timer and another power supply. We had some problems with an arm with the detector stuck in the way at this flange. When we pumped out vacuum, the pressure got very low. They were equivalent of 600 newtons clasping the copper plate in place, and luckily we managed to remove it by pumping in dry nitrogen. Now we're getting to very low temperatures. More power supply control over here, and of course temperature monitors. It's nice and constant at such degrees Kelvin. These are the cryostat temperatures at various points in the ESAs. Our pressure is also very low here, in the -8 range inside the drift tubes, and -7 outside, which is workable. So, earlier today we used this old device to put a negative potential on the extractor, and we recorded some great voltage. Right now there's no extraction potential, and the magnetic field is on at 50 amps, which is equivalent to 2.5 Tesla. This blue pulse over here is the current we're recording on our drift tubes. It is equivalent to about 0.3 to 0.4 microamps, which is very excellent. We optimized this earlier. Here's my logbook, and as you can see, we measured various values. Changing the energy lower, we actually managed to achieve 0.9 microamps, which is roughly 45% transport efficiency into the ESAs. Additionally, this was at a high magnetic field, but the reflector energy was too low. Here's the negative voltage on the reflector. We're going to be using somewhere maybe at the -7 range, which gives us about 0.3 microamps. 0.3 microamps is very workable. I've been able to save these pictures on my flash stick, which is now plugged in over there, so I can record this pulse. The green pulse is just noise on another detector inside. Sorry, it's LA, which is before the port, and the yellow signal is on the extractor. So as you can see, we have very good transport efficiency. There's barely any signal on that extractor, and just noise on LA. LA is just straight after our XY correctors. So after bending, we have a great efficiency of transport, and most of our current is actually arriving there. So, what can I tell you? After lunch, when more people return, we'll be pumping the magnetic field from 2.5 Tesla all the way up to 5 Tesla, which is the workable magnetic field. And shortly after that, we'll be switching on the electron string and turning off my ion supply. Once the electron string is on, we're actually going to begin our very first measurements of charge breeding. So we're very excited about that. Well, I am very excited. Got many high fives earlier, and we're all quite excited and ecstatic. So, hope you enjoyed my update. Like and subscribe. Don't forget to hit that bell so you can be notified the next time I post something back here on Facebook. Thank you very much, and see you next time when I've got charge breeding spectra. Bye for now. Poka poka.